In the previous lecture, we have discussed about the full wave bridge rectifier. So let's see what is the efficiency of a full wave rectifier. In the second lecture, I defined the efficiency is the DC output ratio of the DC output power to the AC input power. So here we have to find the DC output power and the input AC power. The DC output power is given by IDC square into RL because the DC has to be flow through the load resistance alone. But the input AC has to flow through the load resistance as well as the diode. So we have to consider the internal resistance of the diode or the forward resistance of the diode as well as the load resistance. And since we are taking the SC, we have to consider the IRMS. So IRMS square into RF plus RL is the AC input power, and the DC input power, DC output power is IDC square into RL. Now for a full wave rectifier, this IRMS is given by Im by root 2 and IDC is equal to 2 Im by pi. The previous lecture I have shown you how we can calculate the IRMS and IDC for a half wave rectifier. So the same thing here we can use this IDC IDC is equal to, again, instead of t the period we will have 1 by t by 2 into integral 0 to t by 2. The period is t by 2 for a full wave rectifier, and it is capital IM sin omega t dt. If we do this integral, we will get IDC as 2 Im by pi. In the previous case, for a half wave rectifier, we are having the period as 1 by t itself, and we have to integrate from 0 to t by 2 Im sin omega t plus t by 2 to t, it is 0. But here the period itself is t by 2, so we have to use this expression to find IDC, and we will get it as IDC is equal to 2 Im by pi. Now for IRMS also we have to use the same formula. Here it is IRMS is equal to, period is again 1 by t by 2. So it is 1 by t by 2 in the integral 0 to t by 2 Im sin omega t whole square dt. So same thing. So if you repeat the same procedure, you can see that you will from the same procedure you will get this IDC and IRMS. IRMS is found to be Im by root 2 and IDC is given by obtained to be 2 Im by pi. So now we are going to substitute for these expressions in the expression for the efficiency eta. Eta is equal to IDC square into RL divided by IRMS square into RF plus RL. Now here IDC is given by 2 Im by pi. So if you substitute it here, we will get uh, 4 Im square by 4 Im square by pi whole square. That is 2 Im by pi whole square means 4 Im square by pi square into RL divided by IRMS is Im by root 2. So it is Im square divided by 2 into RF plus RL. Now this Im square and Im square will cancel, and this 2 goes to the numerator, so it becomes 2 into 4, that is 8 by pi square into RL divided by, so becomes 8 into RL divided by pi square into RF plus RL. So this is the expression for the actual expression or an exact expression for the efficiency of a full wave bridge rectifier or full wave rectifier. Now we are going to use a particular condition that we know that this forward resistance is of the order of 1 to 25 ohms only, and usually the load resistances will vary from 500 ohm to 1000 ohms or 2 kilo ohms or 3 kilo ohms, etc., 4.7 kilo ohms, etc. So when compared to these high values, this RL will be very much greater than RF. If we incorporate that condition, if RF is very much less than RL or RL is very much greater than RF, we can uh, cancel this RF here. So this RL will cancels. What remains is efficiency is equal to 8 by pi square. 8 by pi square is 0.812, that is 81.2%. So we have seen that and half wave rectifier will have a efficiency of 40.6 percentage, but a full wave rectifier will have an efficiency of 81.2%. So this one, 81.2% means it is the double of the half wave rectifier. So full wave rectifier is much higher efficient than or much efficient than the half wave rectifier. So the efficiency is given by this one. The calculation is important as far as your university examinations are concerned. Now let's see some of the problems uh, to calculate or to the efficiency or something, the mean load current and RMS values by just by solving the circuit. These type of problems are needed to familiarize or to practice solve for solving the different circuit. It will be useful for your electrical experiments as well as electronic experiments. So in the practical point of view, in order to tackle the problems or in order to troubleshoot yourself while doing the practicals, we, we should be familiarized with the problems. So I'm included two problems here for you. So just go through the problems and submit these answers to these problems as a response to your lecture. So that means submit the solutions of these two problems. Some hints are given to you just by writing on a paper and just make it as a PDF or JPG format and attach it as a comment to this lecture which is uploaded in your Google Classroom. Okay, thank you for today and wish you all a nice day. Thank you.